Let's start to see how fast CATOPO is able to analyze large assemblies. First, we import the data from whatever CAD system. In this case, we use the data in step format, and as you can see, this assembly consists of more than 100 single parts. What you see now is really real-time demonstration. It's just a recording what I did on the screen. Here you can see it's a big steel construction, and we had to find out where is the weak area of this construction. First we look at all these parts, and then we start to mesh all these parts. Each part is analyzed during import, and so normally it's not necessary to change any sizes or definitions of the mesh, but we can do it globally for all parts if we like. In this case we do it because all parts have nearly the same thickness but different sizes. After defining this element sizes and the properties for the mesh, we just start the automatic meshing, and this will take a few minutes. I think I expect it will take about 1 or 2 minutes to mesh all this approximately 100 parts. For the time of meshing, I will speed up a bit, will use fast motion. Because it's about 2 minutes we had to wait to complete the mesh, so we can speed up this time, not to waste our time waiting for the end of the meshing process. But you can see the meshing process is still running, so I will not hide the meshing process. I will only speed up a bit. Now the mesh is completed, and as you can see, this mesh is really a very good mesh. Especially if you have small geometrical details, the mesh density is automatically using these small geometrical elements, and so you have a good mesh over all parts. Next step we had to define where we want to load and restrain our model. There's a crane holding this part, and we use a so-called virtual part to have a point where we can put the load in coming from the crane. Next thing we had to do is to connect all parts. It's a welded construction, and we use the automatic search function of CATOPO to find all the welding lines. What we had to define is the gap between the parts, the maximum gap, and the maximum angle these parts have to each other. Nothing else had to be done, and a few seconds later all weld lines of this construction for our first analysis are found. And the next thing we had to do is to define the degrees of freedom of this crane. It's a rope, and so we have to define the degrees of freedom in the right way. Next thing, we had to load with the maximum force, and for that we use 4 faces at the bottom of this construction. This is agreed from the customer we did this project for. And we have a very heavy load here, and that's the reason why we had to analyze this part, if it will really overcome all the lifetime. As you can see, we type in the load here in our form, and our construction is loaded now. At this point, we have defined whatever is needed to analyze this construction. And now we can start our analysis. We will start this analysis in the background. The solver is a batch-able solver. We can run in the background, and we started in the background. And at this point, I will use fast motion, because it's about 10 minutes we need here on the notebook to analyze, and in this time nothing special happens on the screen. We export the data in a Nastran format, so you can use this data also on other solvers if you like. And then after exporting the data is sent to the solver. The solver can run on another computer. There's a queuing system available, and so you can send the solver data to another computer and run it in the background on another computer. Here we have defined the amount of memory we want to use. We can define the amount of kernels we want to use, and as you can see in the bottom, here in the bottom line, we use this special tetra element available in this program. It's a called tetra24 element. It's about up to 15 times faster than the classical 10 element, and gives the same accuracy. And about 10 minutes later, we have completed our analysis, and we can look where are the weak area, possible weak area of this construction. Analysis process is completed, and as you can see, it only took a few minutes to do it. You can see here's a message. And now we import the result data. The job control shows us that the job is completed. We import the result data, and now we can start to analyze our construction. The result data is also in a compatible format. It's a UP2 file or F06 file, used in other pre- and post-processing systems as well. Okay, let's have a look and see what happens. And as you can see from the values here, we really have stress which is too high to overcome the whole lifetime of this construction. And let's look at the place where it is. And as you can see here, at this point we have really high stress. It's too high to overcome, and in the next video I will show you how to optimize this area in a very direct way, and you will see how fast this can be done with CATOPO. And let's go to the next video.